Okay, so completing the square, there's lots of methods to solve quadratics, like we've already covered, graphing and factoring. Completing the square is another one. And you might wonder, why there's so many different methods? Because in certain situations, one method can be easier than the other. Like one method could take like, I don't know, 10 steps versus just 3 steps, depending on how it looks. Plus, this next test, like, is not just gonna be something you could type into Desmos and see the answer based off that. It's going to be like, in what step did this person make a mistake when they completed the square? They'll say what number needs to be added to both sides to complete the square. That's why you still have to know all the different methods. Now, if you haven't had the lesson yet, it is gonna sound like really random, the steps. But if you follow them exactly how they're written, then you will get the right answer. So completing the square, if you haven't had the lesson yet, maybe take a picture of this so that you can do the practice still. If you follow these steps exactly, then you can effectively complete the square. In the lesson, you'll see why it's those steps, like why it happens to make a perfect square trinomial on one side. But otherwise, like in the past, I just said memorize these steps, and then my students did well on the test. So really, if you just memorize these steps, you'll be fine. This really only works so when A is 1, that's why it just says x squared plus bx equals c. When A is not 1, there's like one extra step, and we'll cover that on Monday. But as you can see here, and I'm going to actually probably cut and paste this and do a different problem that you haven't seen yet. So if you want to take out your notes, you can. This is the number 2 that we didn't do, like we told you the answer, but didn't actually tell you how to solve it. Okay, paste. Okay, so first step is to rewrite it to where the x squared and the x term are on one side and the constant is on the other side. Is this already in the correct form? Yeah. Okay, if it wasn't, then you would just do inverse operations, make it cancel on one side, do the same on the other. If it's already rewritten in that form, then you can move on to the next step. Where you take half of b, what's b in this problem? What's half of 12? So we're taking half of b, squaring it, because that's what it says next. What's 6 squared? 30. And then adding it to both sides of the equal sign. That's exactly what the step says. We could talk later about why it's that, but if you just follow the step, you'll be fine. What that does is it creates a perfect square trinomial on the left side. That will be really easy to factor. On the right side, you just have to keep it equal. Whatever you do on one side, you have to do to the other. What's 13 plus 36? And then we're on to step 2, which is to factor the perfect square trinomial. So what multiplies to 36 but adds to 12? 6 and 6. We want to write it in its condensed form, like this, instead of doing x plus 6, x plus 6, write it like this, squared. So that there's only one x to solve for, versus here where there was like 2 other ones and there's no way to combine them. So that's what you do, factor the perfect square trinomial. Then it says take the square root of both sides. So isolating x basically. Take the square root, that gets x plus 6 alone. What's the square root of 49? 7. And remember, anytime we square root, do plus or minus. You have to solve for both cases. most of the time, there are two solutions for quadratics. So this will help us get to those two solutions. From here, if you want to break it up into two separate problems, one where you're solving for the positive 7 and one when it's a negative 7. You're still isolating x though, so what's opposite of adding 6? Whatever you do on one side. And that'll happen over here too. Yes. I do with the trinomials. So over here, 7 minus 6 is, that's one of my answers. Negative 7 minus 6 is negative 13. That's how you get your two solutions without this graphing. That's you following the steps exactly. All right, but I mentioned, I'll come back to this, like I'll leave this up while you work on your practice. But I mentioned that it might not ask just for the solutions on your tests. It'll be questions like this. Like what could be added to each expression to make it a perfect square? So think about it for this one. I don't know if you guys even know, but think about it. What needs to be added to make this a perfect square trinomial? So that's a step where we take half of b. What's b? What's half of 12? That's where we take half of b, square it. What's 6 squared? So adding 36 would make it a perfect square trinomial. And then like when I do factor it, it ends up being a perfect square because it's the same number that makes it work. Does that make sense? Okay, let's try this one. Think about it. Think about what it would be that you have to add to make it a perfect square. Don't tell me, no. Think about it. All right, what's half of b? What is my b? A negative 6. What's half of negative 6? What's negative 3 squared? And that's what I have to add. Even if it has stuff right here, that's what I have to add to make it a perfect square trinomial. Technically, we would have moved this to the other side already, but 9 is what you have to add to this to make it a perfect square trinomial. It'd be negative 3 and negative 3 that make it work. So then, yeah, but 1 would have already been moved to the other side. But any questions, comments? Okay, I'll help you one-on-one. You guys are working on the 12 practice. It should already be there, lesson 12. But some of you are behind. Some of you might have to go make sure your other practices are turned in, or maybe resubmit your coloring activity. To on today's practice, you had to match each equation to the equivalent equation with the perfect square on one side. So if you follow those steps for completing the square, that's how you're getting the correct equivalent equation. But you're not solving it fully, you're stopping until it looks like one of those steps at the bottom. So for this one, first, you make sure that it's rewritten into ax squared plus bx equals c. So is this first one already in that form? Okay, so then you move on to step 2, which is where you take half of b, you square it, whatever that is, and then you add it to both sides. So what's b in this one? What's half of 8? And then we're gonna square it. What's 4 squared? 16, so it's 4 times 4. And then we add it to both sides of your equal sign, like this. That makes the perfect square trinomial on the left side. So that makes it on the left side x squared plus 8x plus 16. So that you can factor and get a perfect square trinomial on the left. So what multiplies to 16 but adds to 8? 4. And so it should be a perfect square at that step. So that you can write it in its condensed form like that. And then also what's 2 plus 16? And even just from doing that part on the right side, that should tell you what your answer is, but also you should know why that becomes that. Does that make sense? Okay, let's try the next one. I won't do all of them right now. Like I'll do some and then you can try the rest. But like for this one, is it already rewritten into the form that we want it? So then move on to step 2. Take half of b, what's b in this one? What's half of 10? Square it, what's 5 squared? And we're gonna add that to both sides. So then on the right side, that's probably easier to pick out your answers from, but negative 13 plus 25 is 12. And then the left side, when I do factor it, trying to multiply the 25 that added 10, it's 5 and 5 that make it work, so write it like this. And what I usually notice is that at this step is what it ends up being for your perfect square. But I prefer you not like try to memorize that from there. Just know how to factor it. Let's look at the one that doesn't have it in this form. So like look at this one. How can I make the negative 5 go to the other side? Yes, you have to do inverse operations. You can't just like pick it up and move it. You have to cancel it out. Good. So then at this step, it's, and I'm not like showing all my work, but at this step, it's x squared plus 4x equals 5. Now you can do step 2, where you take half of b, what's b? What's half of 4? You're gonna square it to be shut. No more talking, find something else to do with it. So you take half of b, which is 2, square it, what's 2 squared? And then add it to both sides. So then on the right side, I have 5 plus 4, which is, and then on the left side, I have something that I can factor. We're looking for what multiplies to 4 and adds to 4. But doesn't add to 4. Oh. It should be a perfect square. Yeah. Okay, so 2 and 2. Then I can write this out as x plus 2 in parentheses. So then you from there try the other one. And then we'll revisit it if we still are having trouble. Yes? Yeah. Because there's no other one over here, so then my constant is 0. All right. Any other questions from anything? Any unit 7 practice? Any other? Oh no.